Welcome to Elasticon. Thank you for dropping by this lightning talk on how we think and do user analytics at Elastic Cloud. My name is Yaru, and I'm a product manager at Elastic Cloud. Today, I will be sharing a story behind our internal analytics platform, belovedly named Cloud Analytics. To begin, imagine that you are part of the product team for a very popular technology that has hundreds of different use cases and applications. This technology can be used to power real-time search for ride sharing or process transmissions from Mars rovers. Now, imagine that you have launched a new feature. It automatically scales this technology so that its users never have to worry about running out of compute power. You've worked with marketing to create campaigns to attract the right personas, sales to create enablement material, and PR to curate the right press release message. And your team is abuzz with anticipation for how successful this new feature will become. A few months after your feature launch, your engineers have been monitoring production closely and report back that the feature is functioning as expected. However, you're not really seeing the anticipated rush of new customers or revenue expansion of mature customers. Marketing wants to review whether you're targeting the right demographic, and the field team wants more tips on setting up their customers for success. So, what do you do now? It would be an understatement to say that understanding how users think and behave is key to making good product decisions. And this is exactly why we need user and behavioral analytics within our product teams. As you may be aware, Elastic Cloud is the hosted service that runs Elasticsearch and Kibana for users. We have many users, some of whom run tens or hundreds of deployments simultaneously in multiple cloud environments. In order for us to discern how they are reacting to new features and what kind of impact these reactions has on the overall business, we need to measure feature adoption and usage. To do this, we use a simple goals, signals, and metrics framework. Signals and metrics are the what's and the hows that we can measure and observe. In the case of our new feature, a metric that we would track is the deployment success rate for proactively scaling up its components. This metric signals to us that the deployment is reacting to resourcing needs and is resizing. More importantly, the why behind the metrics we collect and direction they signal help point us to the user's actual goal. For example, of being able to scale their real-time search seamlessly without performance hiccups. Ultimately, we want to know that we have been successful at fulfilling this user goal. Now, I have just talked about things we can measure and observe with respect to a user's product journey. Before this becomes an elephant in the room, I want to take the opportunity to make clear that we take user privacy very seriously. For the purpose of analytics, we do not store any personally identifiable information. Our intent for analytics is to use anonymized product performance and engagement metrics to make our software better and support the operation of individual deployments. Sensitive fields and PII data, such as IP addresses, email addresses, names, phone numbers, and credit card numbers, are not captured and not stored. For the purpose of analytics, we do capture and store subscription license information, topologies of deployments, product feature usage, and performance metrics. An example of a topology for deployment is the virtual machine type and its size. Furthermore, subscription and deployment identifiers in our telemetry are Elastic company unique identifiers and can't be used to externally identify users. We don't have access to the actual data that passes through your deployments. Our usage and metrics can be thought of as data metadata. This usage and performance data comes from two main sources. The Elastic Stack comprises of Elasticsearch and Kibana instances, while Elastic Cloud hosts many Elastic Stacks in multiple clouds. So, Stack telemetry contains information about individual deployments, and cloud telemetry contains information about how these deployments operate in our hosted environments. Using our previous example of our exciting new feature, Stack telemetry would be able to tell us what kind of modules and functions are being utilized over time, while cloud telemetry would be able to tell us about the actual component types and sizes, how much resources they consume, and more importantly, the number of times they've been attempted and successfully proactively resized. Today, within Cloud Analytics, our internal platform, we have an integrated view of both stack and cloud telemetry. It may not come as a surprise that our internal cloud analytics platform is itself an Elastic deployment. In designing this platform, it was important for us to structure data in such a way that our visualizations and analysis can support both high-level aggregations and detailed drill downs. Elastic Cloud users may have large or small organizations that own multiple subscriptions, each of which may have many cloud deployments. We need to be able to model the behavior at both entity levels to see how feature adoption impacts not just individual deployments, but also the accounts that manage these deployments. Furthermore, we need to track these changes over time to reflect how rapidly users can add or remove capacity from the fleets that we manage for them. In a nutshell, this means that our indices, a snapshot is shown here, are designed with specific levels of denormalization and time resolution. Now that we have had a sneak peek into what kind of data we collect and how they appear in production, let's rewind a bit and talk about how we got here. Cloud Analytics sits in the same production environment as our customers. We are very lucky in that we're able to dog food our own product for improving it. Of course, not all companies are in the data storage and retrieval space, and it makes sense to choose the suitable data platform for you with which to collect and perform your analytics. Democratizing data in any company is commendable, and we hope our experience can provide some inspiration for you. This is our current analytics architecture. It uses a multi-connectivity pull model, where a processor periodically pulls various data sources. The bulk of our data sources are other Elasticsearch deployments. We have a custom processor that performs aggregations, enrichments, calculations, and other transformations. Where possible, however, we always leverage stack components to perform these functions. For example, we receive many data sources by cross-cluster search, a stack feature, from other Elasticsearch deployments, as indices that contain information we wish to add to our main indices. We then turn these information indices into enrichment policies and add them to our ingest pipeline. And in order for data to provide the most value, it should be treated as an asset and be able to move where needed. A lot of our team's work is to promote an open data paradigm to improve transparency and accountability of data ownership and provide our fellow employees with opportunities to lead with data. We empower our product managers to track feature adoption, our engineers to monitor component operations, our marketing teams to analyze user cohorts, and our field teams to drill down on individual accounts' success and failures. There is a place for everyone here, and our analytics homepage is open to all elasticians. We leverage Canvas to create a custom landing page to provide a guided experience in Kibana. To ensure that elasticians are able to learn and self-service our platform, we've created useful tools such as data cheat sheets and data dictionaries, all self-contained within the platform. Meanwhile, we also ensure data privacy with the right access controls. In order for Cloud Analytics to curate datasets and dashboards relevant to each team, we use role-based access control via organizational single sign-on to provision access to spaces within Kibana. With the help of role-based access control, we're able to provide elasticians with relevant, descriptive, and predictive analytics products. At a high level, our descriptive analytics help identify trends and assess product and business performance, answering questions such as, is the adoption of our new feature uniform across user segments? At a more granular level, our most popular descriptive product is a Customer 360 toolset that is widely used to glean insights about individual accounts. The field team, for example, can see how specific accounts are using our new feature, whether the customer started using it on a single environment before propagating it across their entire fleet, and if this has any lasting impact on how quickly the customer account is growing, or even opening new support cases. Going back to the problem we came across at the outset, how does adoption of our new feature impact our overall business? Beyond usage patterns we can see in the Customer 360 toolset, we also create predictive products to help understand the user experience by performing propensity modeling. By analyzing past behaviors, these models help identify the likelihood of someone performing a certain action. In our case, we look at key moments of a customer's product journey, such as trial to paid conversion, in product expansion, and also churning from our platform. Then we are able to compare the propensities of different user segments based on whether they have adopted our new feature and how successfully they were in adoption of our new feature. As we gather enough data over time about the usage of the new feature, we can then incorporate it as part of our original propensity modeling. And so here we are. In the end, our marketing experts can focus on the most suitable new user segment, and our sales teams can optimize enablement and adoption for a new feature. But in order to have gotten here, to have this level of analytics that helps us understand customer needs, we needed a credible and unified data strategy to generate, collect, consume, and action on our data. This has been a short story of how we use our own Elastic Stack to get to this journey. Thank you so much for your time. It has been a pleasure sharing with you.